Continuing our discussion of functions, and today we're going to talk about a subject called function notation. This is a very important thing that we need to present to you and help you to understand. So what do we mean by function notation? Well, let's get into this and see what we do mean. Well, when we think of a function, we think of functions as equations, or a function rule is an equation that describes the relationship between inputs, the independent variable, and outputs, the dependent variable. So we plug in a number, and this little rule acts on the input and sends out a number for the output. So take a look at this equation, y equals 2x plus 5. What is the value of y in this equation when x is 3? Well, what does that mean? Well, that just means we're going to input 3 in for x and then actually calculate the value for that. And so what would that be? Well, we know that 2 times 3 is 6, and 6 plus 5 is 11. So in this case, y would equal 11. Okay. What about this next 3? So we've got 3 different equations. They kind of look a little bit different. But what if we say find the value of y when x is 5? So for each one, we would put the 5 in for x, as you can see. And then we would go ahead and calculate the value. So 4 times 5 is 20. 20 minus 1 is 19. On the next one, it's just 10 times 5, which is 50. So that is the final answer. And then on the third one, we got 7 minus 3 times 5, and 3 times 5 is 15. And 7 minus 15 is negative 8. So that would be your y value in each case for those 3 problems. So when we talk about function notation, we're basically saying that instead of writing y in our equation, we want to start writing this little notation, f parenthesis x parenthesis. And so another way to read that is just f of x. F is the name of a function, and the function has an input value of x, and y is the output. So it's going to start looking like this. F is the name of the function, x is the input, and here is the rule that the function does when you put in a number. It multiplies whatever the input is by 2. I want you to keep in mind that this f of x still represents the y value. We're just using some different letters to represent it now, because as we start exploring lots of different kinds of functions, they may not all have x's and y's in them. So we need to know how to use them still. So when the equation used to be written as y equals 5x, now we'll write it as f of x equals 5x. Y equals x plus 7, you could write any one of a number of letters, but g of x equals x plus 7, or y equals x squared, you can change this to h of x equals x squared. And quite often the letter that you put in there maybe have something to do with what it is that you're looking for with this function. So that's what we call function notation. So one thing that this is helpful for is that you read this f of x, and you think the output of f for the input of x. So on this next one, read f of 3. So think the output of the function f if I input the number 3 into the value. So that still may sound kind of confusing to some, so let's see what we're talking about. So what we're saying is that if I write the equation f of x equals 4x minus 8, that's the same thing as writing it as y equals 4x minus 8. But there is a reason why we want you to start writing it with that f parentheses x in it in place of y. So when you write it in this form, the function notation helps you evaluate the function for a specific given value. So if I ended up writing f of 3 like this for this particular function, then that would mean I would have 3 plus 9. So if I have an input of 3, what would be my output? Well, 3 plus 9 would be 12. So pretty straightforward. All right, so how about this one? We got g of x equals 2x plus 1. And what happens if I put in -3, -1, and 2? So then all I would do is write 2 times -3 plus 1, or 2 times -1 plus 1, or in this last one, 2 times 2 plus 1. And of course, the final answer for each one, 2 times -3 is -6. -6 plus 1 is -5. On this one, 2 times -1 is -2. -2 plus 1 is -1. 2 times 2 is 4. 4 plus 1 is 5. So that's what we're talking about when we stick a number in, evaluate it for that value, and then this is your output. Okay, so you could be given a problem like this on ALEKS for an assignment, and what you'll do is you'll end up plugging these numbers in for the x value in this function up here. So on the first one, you would have 4 times -5 plus 1. And 4 times -5 is -20. -20 plus 1 is -19. On the next one, you will have 4 times -3. And -3 plus 1. So 4 times -3 is -12. -12 plus 1 is -11. How about 4 times 1 plus 1? 4 times 1 is 4. 4 plus 1 is 5. Let's do 4 times 3 on this next one. 4 times 3 is 12. 12 plus 1 would be 13. And the last one, 4 times 4 is 16. 16 plus 1 is 17. So that's how you would insert those input values into the function, and this is what you would get out of it. Okay, so we could also look at a word problem and kind of see something like this. Jenny earns $51 per week working part-time at a bookstore. She makes $1 more for each book that she sells. The amount A in dollars that Jenny earns in a week if she sells B books is given by the following. A equals 51 plus B. How much does Jenny earn in a week if she sells 17 books? So you'd end up with A equals 51 plus 17, and that equals 68. So she'd make $68 if she sold 17 books. All right, how about another one? Jessica rented a truck for one day. There was a base fee of $9.25, and there was an additional charge of 9 cents for each mile driven. The total cost, C in dollars, for driving X miles is given by the following function. All right, so what is the total rental cost if Jessica drove 40 miles? And so we might want to rewrite this as the function or cost is a function of X, and we have 0.09X plus 9.25 for the $9.25. Okay, now what is the total rental cost if Jessica drove 40 miles? So when we plug it in using the function notation that we've been talking about, we write it like this. Equals 0.09 times 40 plus 9.25. All right, and when we do that, we end up with the cost for 40 miles is going to equal, and this would be $3.60 plus $9.25. So 3 and 9 add up to be 12. So this is going to equal $12.85. So that's one way to use a function in a word problem. Okay, so we'll skip this one, but this is very similar. Rachel's total pay if she sells 23 copies of software, and it's the software that History is Fun that she sells. So you can kind of figure out how much that she would make doing that. Okay, now on Alex, you're going to see some problems like this. You're going to be given a couple of different functions, f of x and g of x, and it will give you a value for x to plug into the f function. So that would just be -2 times 7 minus 1. And -2 times 7 is -14, and -14 minus 1 would be -15. On the next one, we would put -2 in for x in the second equation. So you'd have 2 times -2 squared minus 3 times -2. Well, -2 squared is 4. 4 times 2 is 8. And -3 times -2 is +6. So this whole thing ends up being equal to 14. So for these input values, these are the output values for these two separate functions. So -15 and 14. All right. So your assignment is going to be on Alex, and it's entitled Function Notation. So good luck. Let us know if you have any questions.